All right, guys. So we've got our day 8 review, and we had a chance to work on problems 3 through 6 yesterday. So I just wanted to kind of briefly let you see what was going on there. Now, on these problems 3 through 6, these all came from days 3, 4, and 5 over translations, reflections, and rotations. So, for example, on number 3, they gave you this coordinate. Negative 3b was our point. They said, hey, we're going to create a new point by taking this, flipping it across the x-axis. So in other words, if it was over here, we're going to flip it down here. So when you go from here to here, that's going to change the y sign. So if it was a positive b, now it's going to be a negative b. And then we also are going to translate 4 units to the right. Well, that means whatever the x value is, we're going to add 4 to it. So 4 plus negative 3 gives you 1. And if it was b and we flipped it, then that's now negative b. Same thing for number 4. A and 5 is our starting point. We're going to flip across the x-axis again, so we change the y sign. It was 5, so it becomes negative 5. But then we're also going to go 7 units to the right, so we're going to add 7 to x. In this case, x is a, so we're going to have a plus 7. And then after flipping this from 5 to negative 5, we're then going to go 5 units up. So we're going to add 5 to negative 5, which is what that changed to when we flipped it. So negative 5 plus 5 gives you 0. And then finally, number 5, it's a lot of 5s. 5 again here, we're going to use point J, 5, 10. We're going to reflect it across y equals negative x. That is a diagonal line that looks like this. You can see right here. It goes through the origin. And when you take this point, which is 510 will be up here, and we reflect it across a line kind of like that, that's going to put it down here. So we're going to have negative, negative. Also, when you flip it across a line like this, x and y flip. So 5 and 10, it's going to flip around, and they're both going to become a negative. So when we reflect it across this, 5, 10 becomes negative 10, negative 5. So rotate it and change to negatives. But then from there, we're also going to translate m units to the right. That means we're going to add m to x. So x is negative 10. So that means we're going to have, I'll put it over here, negative 10 plus m. And then we're going to take negative 5, and we're going to subtract n and go n units down. So that means we're going to take y and subtract n from it. So negative 5 minus n. We got a really weird x and a really weird y. Now, page 2. This is all day 2. So if you want to know where all this day comes from, it's all from day 2. So actually, I'm going to pause. I'm going to pause the video. And I'm going to let you guys see if you can work through 7, 8, 9, 10, 11, and 12. These 3 and these 3. I'm going to let you try them all. So you can pause the video. So starting off, we see we've got a quadratic in standard form, which means we're going to have to work a little bit harder to find the vertex. So we do to find the x of our vertex, we're going to do negative b over 2a. So negative 18 over 2 times negative 3, which would be negative 6. Negative 18 over negative 6 is going to give us positive 3. Well, that's the x of our vertex. We got 3, but to find the y of our vertex, we got to take 3 and plug it back in to our x's. We take the input, we plug it in to get our output. So when you plug 3 back in, that becomes 3 and that becomes 3. And you end up getting, when you work this out, all that becomes 20. So we've got 3 and 20 as our vertex. Well then, they want us to take our vertex and translate it 5 units up and 8 units left. So 5 units up means we're going to add 5 to 20. 8 units left means we're going to subtract 8 from 3. So our new vertex would be -5, 25. Okay, we know axis of symmetry. That comes from the x of our vertex. And we're using the original. We're using that original vertex here. So x equals 3. As far as min or max goes, that's all based off the number out front. Is that 3 a positive or a negative? Ooh, it's a negative. Because that's a negative, that means we've got a max. We have a graph that looks like this, upside down, which means your vertex is at the top of that graph. It's a max at, and it's always based off the y of your vertex. Y equals 20. As for the next section, I think this is a little bit easier. This is in vertex form. Don't forget, guys, you can use Desmos too. You can use Desmos to find the vertex. So you can always use that to find the vertex. But we don't need it here. There's our x, there's our y. HK. So your vertex is going to be 5, 1. And again, we want that to be a minus. If that was a plus, we know that'd be a -5. Now, they want us to now take that vertex, reflect it across the y-axis. Oh, that means if we're on the left side, we're going to go to the right side, or if we're on the right side, we're going to go to the left side. So that's going to change the x. So if it's 5, 1, reflect across, I'm sorry, that is y. Reflect across the y-axis, change the x sign, 5 becomes -5. And then we're going to go right 6. So right 6 means we're going to add 6 to -5. -5 plus 6 gives us 1, 1. So we did 2 things there, guys. Reflect across the y-axis, and then add 6. And finally, last 2 things here. This is the only tricky part about vertex form. If you want to find the y-intercept, we know we're going to make x 0. You're going to plug that in for x. So 0 goes into x. See that here? You work that out, you end up getting 126. So there's your y-intercept. And finally, a +5 out front means we got a smiley face. We got a minimum. And that vertex is going to be, its minimum value is going to be at, so we look back at the original, going to be at 1, based off the y. Actually, this one right here. All right, guys, so now on to page number 3 of our review. We know a bag contains 10 red marbles, 5 yellow balls, and 9 white balls. So the first thing I would do is I'm going to add these all up, 10, 5, and 9. So how many total balls do we have in this bag? Looks like 24 total. And that's going to be really important whenever we start to find these probabilities. So what's the probability that an individual will draw 1 ball and that it will be yellow? Okay. So the probability of getting a yellow ball, that's going to be 5 out of 24. That's not too bad. Now, this is where things get a little bit tricky. We're going to draw a ball from a bag and put it aside. In other words, we're not going to replace it. Keep that in mind. We're not replacing a ball if we draw it out. And then we're randomly going to draw another ball. So what's the chances that when we draw these 2 balls out of this bag, they're both yellow? So probability of both being yellow. Okay. So we already know the chances of drawing a ball out of this bag and it being yellow. For our first ball, we know it's going to be 5 out of 24. Very straightforward. But here's the thing. We're going to get another ball. And we need both these things to happen. So both means we're going to multiply these probabilities because our chances are actually going to be smaller. So when we multiply fractions, that actually makes our fraction product smaller. Now, if we took a ball out and we go to take another ball out, How many balls total are left in this bag if we didn't replace after the first one? Looks like we're going to have 23 left. And if we want this one also to be yellow, and the first ball we drew out was yellow, wouldn't that mean there's only 4 yellow balls left? Yep. So we multiply, you end up with 20 over 552. Which whenever I type this into a calculator, which would be a smart move, 552, I get an awful decimal, math, enter, 5 out of 138. So in other words, not great odds. Not great odds at all on that one. Now, as far as part C goes, suppose that once again we're drawing from a bag, but this time we are replacing, and then we're going to draw another ball. What's the probability that we get a red ball first and then a yellow ball? So the probability of red and yellow. This is going to be a little bit more straightforward. How many red balls are in this bag? Oh, 10. So we got 10 out of 24. And then it's an and problem. Once again, we're talking multiplying. Anytime you see that word ands. Times, we replace that ball, so there's still 24 left. And the chance of getting a yellow ball, we already know, it's going to be 5 out of 24. So now we multiply these, you get 50 out of, I actually don't know, 24 times 24, 576. And when I reduce that fraction on my calculator, I get 25 out of 288. 25 out of 288. Nice. Now, for page 4, guys, this is going to be one of our free responses. So this is a big problem right here. This is going to be one of our free responses. It's going to be really the last part of our test. And these can seem a little challenging till you really break them down. So psychologists studied the number of puzzles that a subject was able to solve in a 5-minute period. So in other words, they tested some subjects and said, hey, here are the number of puzzles they were able to solve in 5 minutes. So Z is going to be the number of puzzles they completed in that time period. So the value of Z. So this will be 1 puzzle in 5 minutes, 2 puzzles in 5 minutes. They solved 3 puzzles in 5 minutes. Or they solved, can you imagine this? 4 puzzles in 5 minutes? Oh my goodness, they better be small puzzles. And then down here is the probability of each of these events happening. So these are number of puzzles solved, and this is the probability. So number of puzzles solved and the probability that each of these events happened. So watch carefully right here. Watch carefully. What's the chances that I choose somebody that completed at least 3 puzzles in the 5-minute period? So the probability of Z being at least 3 puzzles, that'd be greater than or equal to 3. In other words, 3 or more. What are the chances that we pick somebody who did 3 or more puzzles in a 5-minute period? By the way, what kind of music do you think they were listening to? I'm thinking smooth jazz for our music there. Oh yeah. Well, what were the chances of them completing 3 puzzles? Okay, that'd be 0.3 plus, well, what was more than 3? I guess if they did 4 puzzles, that was 0.1. So hey, about a 40% chance that we would choose somebody at random that did 3 or more puzzles. So I'm going to let you guys try number 16 for me. See what you get here. Okay, so what's the chances that we choose a subject that has not completed more than 2 puzzles? So in other words, 2 or less. So 0.4 plus 0.2 gives you 0.6, or about 60%. Now for this last one that's involved with this section, find the mean expected number. So when we say the mean expected number, we're talking about taking all these probabilities, adding them all up to find an average. So check it out. So we're going to take each event, solving 1, solving 2, solving 3, solving 4, and we're going to add them together after we have multiplied them by their probability of happening. So for example, solving one puzzle, we know there's a 0.2%, or we know there's 0.2 or 20% chance of that happening, plus solving 2 puzzles, 40% chance, plus solving 3 puzzles, 30% chance, plus solving 4 puzzles, about a 10% chance. And when you work all of that out, I believe you end up with, I think it's 2.3. We'll see if I'm right or wrong here. Yep, 2.3. So on average, subjects solved 2.3 puzzles. So on average, subjects solved 2.3 puzzles in 5 minutes. Yep. So hey, this is kind of a fun little idea. What if another subject, which we'll represent with Y, so this is another subject, can complete 3.1 puzzles, an expected number 3.1 puzzles in 5 minutes? What would their combined effort be here? Oh, okay. So what would be the combined mean of that? Well, we take our subject, this is Z, which is 2.3, and we're going to add that with, remember it's combined mean, we're going to add that with the mean of subject Y. Okay, so they could solve, if they work together, they could solve 5.4 on average if they work together. Nice. So if they work together, they could solve about 5.4 of those. And then finally, guys, to wrap up, last thing, we're given a new table, variable X. So these are events. We don't kind of know what they are. But here's the probability distribution for each of them. Now you're going to notice we got W's in here. We want to find out how to find the value of W. Now at first you're probably thinking, wait, okay, what does this have to do with the probability? Well, let's think. What do we know all these events have to add up to be? What wouldn't that be? These all have to add up to 100%. Now, how do we represent 100% as a number? We know 30% is 0.3. Isn't 100% 1? Yeah, so if we want to do this to find out what W is, let's turn it into an algebra problem. 6W plus 4W plus 8W plus 7W plus 15W. It all has to equal 1. So we combine those together, 10, 18, 25, 40W equals 1. And so how would we solve for W here? We add these together, combine like terms, 40 times W. Let's divide by 40. And W, don't write this as a decimal. Let's leave that simple. Leave it simply as a fraction. 1 over 40. So guys, remember, test tomorrow. Tell your friends. Tell your friends. And I will be seeing you guys tomorrow. Thank you.